Now, part two, narrow from journal DFIR into window file system that underpins almost every disk investigation. For example, NTFS. The subtitle highlights MFT, timestamp deleted files, and MFTF CMD tools. Those are in the Eric Zimmerman tool. You will practice most here, not in this lecture, maybe in subsequent lecture series. The subsequent lecture in this series. For example, even if a malware is gone, the master file table MFT often still remember the file name, times, and parent folder. So, what do you learn from this lecture? The learner will be able to describe NTFS structures that matter to DFIR, explain MFT records and resistance versus non-resistant data, interpret MACB times and time stamping clues, extract value from deleted orphaned records, and practice MFTE CMD, MFTE Explorer, and FTK Imager. For example, given a exported MFT, produce a CSV and find them in some location like C users Bob desktop and secret.xl was created and when and whether it was deleted or not. So the diagram link VBR boot MFT file data cluster with side link to metadata log file, user journal, and indexes like I30. Explain that MFT is a master catalog and the USN journal record changes and log file support transactional recovery advanced. For example, renaming report.docx to report.zip is not only a directory change, it can leave USN journal evidence even if the user empties recycle bin. Walk through the record anatomy header, in use flag, standard information file name, data, residence or non-residence, and the other attributes. Resident files store content inside MFT. Non-resident files use data run to cluster. For example, a tiny.url internet shortcut may be resident and recoverable from MFT alone, while update.exe is byte live in clusters that may be overridden after delete even if the MFT metadata remains. MACB means modified, assessed, changed, MFT entry change, and born created. Stress that Windows commonly expose two timestamp set, SI and FN, that often disagree after copy move or anti-forensic stamping. For example, an attacker set SI created to 2019 to look old, but FN creator still shows yesterday. MFTE CMD side by side column make that inconsistency obvious. The decision flowchart teaches a method. Parse with MFTE CMD tool and ask if SI is equal to FN. If yes, treat as likely normal. If no, consider timestamp copy artifacts. Always collaborate with Perfetch, USN, or log file. For example, SI created much newer than FN created on payload.dll after a copy from USB stick is common and not automatically malicious, but SI modified older than FN created can be a stamping red flag worth pivoting on. Deletion typically clears the in-use flag rather than instantly wiping content. Cluster remains until reallocated. Parents path recovery and recycle bin artifact I/R add content. For example, user delete some file at the location C temp steel.ps1. MFTE CMD still shows the record with in use false and original path. If the cluster are free, carving or remnant string B strings may recover script content for confirmation. Using journal change workflow, journal flow. The create, rename, modify, delete flows into the user journal. Column J shows why the journal is powerful for restructuring file. Life cycle demands static MFT snapshots mentioning MFTE CMD tools with USN option, NTFS log tracker and distring. For example, the malware dropped as invoice.pdf.exe, then rename it to some other file name like svchost32.exe may still shows both names and reasons in USN even if the directory listing look clean. Now this is the hand-on pipeline. Export MFT via FT kmeasure and then MFTE CMD and then CSV body file and then timeline explorer. Include the sample command line so you can type it uh, inside any virtual machine which you want to practice. So also mention also here it is important to mention that MFTE Explorer for GUI explorations and analyze MFT or Topsy as alternatives. For example, filter CSP for slash temp folder and sort create 0 cross 10 to find newest drop binary. So we soon will do the hands-on practice with this as well. The dropper scenario ties the module together. So use MFTE CMD for lifecycle, compare SI and FN values, check USN for rename tricks, and then pivot to execution artifacts in next part. So what is the takeaway from this is MFT is the foundational uh, step and always compare SI and FN. Deleted is not gone and practice tools like MFTE, CMD, MFT Explorer, TFC Imager, Timeliner Explorers. So far you have learned the tool name at least. So when you do the hands-on practice, you will get these things in more details. So, for example, the MFTE CMD tool shows update.exe created on a specific date and the time. And FNSN matches and USN rename from invoice.pdf.exe. Support intentional concealment. So, such sort of scenarios we need to create and we need to practice.